Now there's one other way that we're going to refer to unit vectors in this lesson, and that is they're called standard unit vectors. And they basically act like x and y. So we're going to have these two vectors. They have the little hat over them instead of a vector symbol, instead of a little arrow, because there's just not enough room to write that little arrow. So we sometimes call them I hat and j hat. I hat is, you'll notice 1, 0, so there's a 1 in the x component, which means that that is essentially just a vector that has an x value of 1 and nothing else. J is like it in that it is just the y version of the same thing. So if I were to take what we had before, pointy brackets, call it like a vector 2, 5, and I were to convert this into the form with i's and j's, you write it in a little bit different way, but it means exactly the same thing. The way to write this one, it would look like 2i hat plus 5j hat. It's not super important that we always do it in that format. It's just that if you see those later on down the road, that you'll know what they mean. So for a couple of examples, we're going to have a little bit of practice at that, and what I would say is that just use this as the last step of your process. You'll see what I mean here in a second. Here are the examples that you hopefully found in your printed notes. It says to write the vector 8, 4 as linear combination of the unit vectors. Basically, look for that phrasing, linear combination of the unit vectors. That just means I hat and j hat. So 8, 4 is the same thing, kind of like we were just talking about. It's just 8 I hat plus 4 j hat. That's all it is in that problem. Now this one, number 2, actually goes back to the previous example where we were talking about writing a unit vector in the direction of a certain vector. So this time we're just using 8, 4. I would actually always start this in component form. I just like component form better. And so I would start this as 8, 4, divide that by the magnitude. So then we've got 8 squared plus 4 squared. We continue on with this one. So that is still, let's see, that's 8, 4 over, and this ends up being square root of 80. And that'll simplify here in a little bit. We'll talk about that soon. So then we get this distributed, square root of 80, and then 4 over square root of 80. And one thing that's important to note is that square root of 80, just as a side problem down here, square root of 80, if we simplify that, that is going to be square root of 16 times square root of 5, and so that's 4 square root of 5 as a simplified version of that. So I'm just going to rewrite this again. So that's 8 over 4 square root of 5, and then 4 over 4 square root of 5. And then I'm also just going to simplify as I can here. The 8 and the 4 get chopped down. We get that as 2 over square root of 5. And then 1 over square root of 5. And like we have been doing, we should simplify. So that means multiply top and bottom by square root of 5. That gives us 2 square root of 5 over 5 and square root of 5 over 5. Now this is not in the format that they want us to. They wanted us to write it as a linear combination of the unit vectors, just like up on top. So once you're completely done with this problem, then I would just take what we have here and write it with the i's and j's. And so now that just means 2 square root of 5 over 5 I hat plus square root of 5 over 5 j hat. It's really just rewriting it. I only work with that in the very end if that's what they're asking me to do, but otherwise I just like to work with pointy brackets with the component form instead.